We are going to add up two vectors which are at right angles to each other. Take a moment to look at the example here. Is find the resultant of two velocity vectors in this case, 6 meters per second east and 9 meters per second south. First thing we're going to do is to make a sketch. This doesn't have to be a scale diagram, but a reasonable sketch of the addition of these two vectors head to tail. You might want to pause and make that sketch on your own. Here we go. North is towards the top, east is to the right. And so I'm going to draw the first velocity as 6 meters per second east. So I'll just draw a vector pointing east and label it 6 meters per second. And then I'll draw the second vector head to tail with that and pointing south. So 9 meters per second south. I'll make it look convincingly longer than the 6 meters per second, 9 meters per second south. So those are the two vectors I'm going to add up. All right, the resultant of these two vectors is going to be drawn from the tail of the first to the head of the last. So I'll draw that vector reasonably carefully, and I'll label that R. And I wish to know the magnitude and the direction of that resultant. I'll be doing two calculations, and the first one is to find the magnitude, which I will write over here. The magnitude of that resultant I'm going to find using the Pythagorean theorem. This is a right triangle because it's a right angle between east and south. If you want to make this look more like math class, you can say that this is side A, 6 meters per second, this is side B, and the resultant is side C. Pythagorean theorem tells us that c squared is a squared plus b squared. So I'm going to substitute in 6, and I'm going to include the units for side A, 6 meters per second squared, plus 9 meters per second squared. Okay. Now the next line doesn't have to be in the solution, but I'm going to write it down. This is 36 square meters over square seconds plus 81 square meters over square seconds. And that is 117 square meters over square seconds. And now on my calculator, if I find the square root of 117, I get 10.8. 10.8 meters per second. So I square rooted the number and I square rooted the units. That is the magnitude of the resultant, 10.8 meters per second. Step 2 is to find the direction. And the direction of the resultant would be the angle that that vector points measured from some reference direction. Well, here's a convenient reference direction, this vector pointing east. So I'm going to find this angle. Notice that the angle I'm looking at is at the tail of the resultant, because that's going to show me which way the resultant is pointed from. So I'm going to find the angle where the tail of the resultant makes an angle with a reference direction, in this case east. All right, I'm going to again take advantage of right triangle trigonometry. And again, these formulas are on your reference table if you want to look those up. I can use either sine, cosine, or tangent of that angle to find the angle, because I know all sides of this triangle now. This is 10.8 meters per second. I don't know why I like sine so much, I just do. So I'm going to write sine theta is opposite over hypotenuse, which in this case would be side B over side C. You can just leave it as opposite over hypotenuse, that's perfectly fine. Okay, line 2 of my 3-line minimum, I'm going to substitute in opposite, which is 9 meters per second, it's got units, and the hypotenuse is 10.8 meters per second. Now, I'm going to divide this out. 9 divided by 10.8, and I get 0.833. I'll write out a few digits there. That, remember, is not the answer. I'm looking for the angle. And so now on your calculator, you have to do the inverse sine of 0.833. And that should give you, make sure your calculator's in degree mode when you do the inverse sine of 0.833, and that should give you 56 degrees as the angle. And so the final answer would be that the magnitude of the resultant is 10.8 meters per second, and the direction of the resultant is 56 degrees. My reference direction is east, so it is of east, comes after the of, and that vector is pointing south of east. So it's 56 degrees south of east, and I am done.